Alright, so I told you I'd put a video up on balancing equations, and I'm going to try to do this as best I can from at home. I don't have my tripod here, so I have to hand hold it, so I'm sorry that it moves. I hope I don't make any of you too motion sick by doing this. So here we go. We're going to work through a couple of equations. This will be the first one. This one says iron plus chlorine produces something called iron 3 chloride, FeCl3. When we balance an equation, we want to make sure we know what's out of balance. That's why I made these two lists at the bottom of each side of the equation. Over here we have our iron and chlorine for the reactant side. One iron. 2 chlorines. I wrote 2 chlorines. Over on the product side, no subscript there, so there's 1 iron. Subscript of 3, so we have 3 chlorine. So we can see our chlorine is out of balance. We have 2 on the reactant side, we have 3 on the product side. There's really no way to make the product side even. There's no way to make it 2. There's no way to make the reactant side odd or make the number of chlorines 3. So we're going to look for that lowest common factor. And the lowest common factor between 2 and 3 will be 6. So we're going to try to get 6 chlorines on both sides of the equation. And we're going to start over here. And the reason why we're going to start over here because this is a compound. And we want to try to start with the compounds. That'll make the major changes first. And we can save these elements so we can fix things at the end. So let's go ahead and get our 6 chlorines on the product side. We'll do that by multiplying that subscript 3 by a 2. And we're going to write it in front of the compound as a coefficient. And there it is. Coefficient 2. It distributes all the way through the formula. It's just like using the coefficient in math. So we'll take 2 times 1 for 2 irons. 2 times 3 for 6 chlorines. Now we have to get 6 chlorines on the reactant side. We already have a subscript 2 here, so we're going to multiply the chlorines by 3. And again, we write it out there as a coefficient out in front. 3 times 2 gives us 6 chlorines. It does not affect the iron because of that plus sign. They're 2 different things. When we have a plus sign, we know we have 2 completely separate substances. So the iron is still 1. It's a problem because we need 2. If we go over to the product side, there's our 2 Fe's. We need to get 2 over here. Simple fix for that. We're going to stick a 2 out in front of the Fe. And when we do, again, it only multiplies through the Fe. It doesn't go past that plus sign, so there's 2 irons on both sides. And that is a balanced equation. Once these two lists are the same, our equation is balanced. It's always a good idea to go back and make sure that we can't reduce our coefficients any. We have a 2, a 3, and a 2, so those cannot be reduced at all. That's the first one. Very typical example of the kind of balancing that you would have to do in physical science. Let's do one more. In this one we have mercury 2 oxide, HgO, producing mercury and oxygen. And again, I made a list of both sides of the equation so we knew what was out of balance before we started. No subscript on the Hg means there's one of those. No subscript on the oxygen means that there's one of those. Go over to the product side. No subscript on the Hg means there's one of those. Subscript 2 on the oxygen means we have 2. So our oxygen's out of balance and we need to fix it. And once again, we're going to fix it with the compound first. Always try to start with the compound. Save these elements for last. The elements allow you to do a little fine tuning. So make your big changes first, fix what you did with the elements. We have 2 on the product side. We can get 2 on a reactant side this time by simply sticking a 2 out in front of the HgO. When I do that, it does multiply all the way through the formula. So 2 times 1 gives us 2 Hgs, 2 mercuries. 2 times 1 gives us 2 oxygens. It fixed the oxygen problem, but it threw the mercury out of balance. Now we have to fix that. And it is a very easy fix because we saved these elements for last. We have mercury over here. We can get 2 mercuries by sticking a 2 out in front of the Hg. And when we do that, both sides are the same. We check our coefficients, make sure we can't reduce. 2, 2, 1. That cannot be reduced. That is a balanced equation. Now I'm only going to do 2 on here, and the reason I'm only going to do 2 is because they're all different. And you really have to practice this to get good at it. It's not just something that you can watch somebody do and become a master of it. But that should at least give you, again, something to look at as an example as you're balancing. How the process goes, how the technique goes to learn how to balance equations. And you should never have to balance anything except synthesis and decomposition, so it really shouldn't get much more difficult than this. While I was looking for equations to balance, I came across this website. It has a little tutorial on balancing equations, and it does use a simple decomposition reaction as its example, so it's the same kind of equation that you'll have to balance in class. Now, if you want to go to this website, read through the tutorial, watch what they do, again, it's another good explanation of how to balance an equation. Let you see another example. Let you hear somebody else talk about how to do it. That way it's not me all the time. If you have any questions, leave me a message on the wall or send me a message through Facebook or talk to me about it in class.